Okay, good morning. This exercise here, what is the equation of the tangent line of the graph of fx equals 2x cubed plus 3x where x equals 2? Does anybody feel like you got somewhere on this?
A little bit.
A little bit? Okay, what was the strategy on this one? And this is just kind of introductory since we first looked at the power rule yesterday, right? So what are the things we need to find for the equation of a line?
Slope and a point.
So we need to have a slope. Thank you, Aaron.
You're welcome, Mr.
And a point. And then you kind of look for what you have here, and what do we have already?
We have,
Who erased your name?
What do we have here?
the x.
Because I know you think I'm.
Okay, we have an x coordinate, so I'm going to go ahead and put that like that, okay? So what's the next thing to do here?
You gotta find. I don't know. Well, I did it, but I don't know what you're thinking of.
Yeah, well, I'm just asking you because what it is, for a lot of these things, there's not a prescribed order for things, but
Or can't you just plug 2 into fx and get?
yeah, so let's do that. Now, we didn't have to do it at this point, but if we did it now, that's logical to do it, right? So we have 2, and then we're going to have 2 cubed plus 3 times 2, right? So what do you get? 8 times 2, what is that? 16 plus 6, so that's going to be, okay, 22. Okay, good. So now we have our point, and then what next?
You use the point to get the slope.
Okay, we need, what is our slope?
You gotta find the
The
derivative
slope
of it.
form.
So let's go ahead and find our derivative here. So we can find f prime of x, which is going to be, what's f prime of x?
It's gonna be,
You'd move. Oh, okay. Yeah, you move the 3 to the front.
So it's 3 times 2,
3 times 2.
6
6,
x.
6x.
x,
3 minus 1 is 2.
2, okay, plus
That would just be 3, right?
plus 3, okay? And now we're going to have now to the viewers of this video, should there be any, this is something that they just did yesterday. We just started the power rule yesterday, so they're not nearly as adept at this as they soon will be. So now we have 2 squared, right? Plus 3, what is this going to be?
27?
20, that's going to be 4 times 6, that's 24 plus 3. I'm thinking 27 looks pretty good.
Nice.
So what I do is I go ahead and put this m sub t equals 27. And so now we just write out our equation, which is
It's
Y minus
y minus
y1, which would be 22.
22 equals
27.
27.
X minus 2.
Okay. So that's it. Okay, so, and this is kind of putting together what we did yesterday with finding the tangent line. So this is an exact equation. This is the answer to the question that we had. Remember, we had the calculus roller coaster at the beginning of the year? And we did that average rate of change, the slope of the secant line. This is the exact slope, 27, at that point on the curve. All right? Let's go ahead and go to these exercises. Gavin, did you watch the video from class yesterday?
I like to know.
Some of it? Yeah. Okay. Well, basically, that's where we're headed. And so the video is really for you and Maddie.
Yeah, I saw that.
I had, okay, so here we are, and the purpose of this section is to articulate different ways of saying the same thing. Okay, so how is this question, this of what the slope is at a point that we had in that last problem, how is this going to be asked? Okay, so here we have, and they're using the same function, which is actually pretty similar to the one I demonstrated earlier, right? And so when we say find f prime of -1 for this function here, here is another, this is the same thing, but differently articulated. The instantaneous rate of change of f of x at x equals -1. They should have said of somewhere here. Okay, here's another one. Find the slope of the line tangent to, so this is very similar to the example I gave you, right? Except not quite, because that's the slope, but the one I gave you was the what? The actual equation of the line. So we have that. Here we have find the derivative of y with respect to x, or dy dx when x equals -1. So that's how you'd say it verbally, and this is how you'd write it, dy dx. This one here, okay, that's already, this one here, remember yesterday we talked about this ddx thing? Did you remember that yesterday?
Yeah.
Sometimes you'll see ddx and just have the whole expression parenthesized like this. Okay, so that's another way of saying that. Then really, okay, that's that one. Okay, so that's it. So what I want you to do is go and work through these ones here, and work through number 10 on these really quickly. You should be able to work through number 1 through 10. I'll just go over you. It should take you about 3 minutes, and then I'm going to go over those quickly. All right?
10?
1 through 10. If you need to consult with a neighbor on this, that would be fantastic. That would be what I want, really.
Isn't it, if it's a constant, it's 0?
Yeah,
Nice.
that's what I mean, maybe. It's like 3 in the center, but also snake a pi, that's a constant. That was also sneaky, trying to make us think of it. You're a sneak, Mr. G.
Sneak. Oh, sneak, yeah. You know that already.
That's what I got.
I'll watch the intro.
Oh, we can't have negative exponents.
I got 3 new things.
She didn't know that.
How big is the one side of
And then negative 5 over x.
Watch it.
They're too small.
No,
Yeah.
5 is too
It
big.
shouldn't be right.
I know it's 5, but it's too big. No, like, it would be too big for you.
Oh,
Or 7 too.
Okay, we'll go over these pretty quickly. Okay, and what different ways could you write the answer? Yeah, any of those, right? So which one do you want to use?
The first one.
What I'd like to do most of the time is write it like this.
Oh.
Okay. So we have that, right?
I forgot to write F prime.
And then you could also write this as ddx of negative 50. And what is the derivative of that? 0. Okay. This one here, f prime of x is equal to
Which one number?
3,
It's 0.
0. Okay. And yeah, was this the one you were talking about that was sneaky here? Here.
No, the one underneath.
One, but this was a little bit sneaky because it's sort of made to look like a variable. That's a little bit sneaky, but yeah,
I
there's
was
other.
talking about the pi.
Yeah.
See,
So this one here is going to be f prime of x is equal to 0. This one here, f prime of x is equal to
4x to the third.
Shoot.
4x to the third power. This one here, f prime of x is equal to
9x to the 8.
9x to the 8th. We have this one here. This
Ready.
one, f prime of x is equal to
Which one is that? Number 7? I got negative
Co-op game.
5x to the 6.
Wait, why do you have it on the wrong foot? Oh, wait, no, you don't. Her legs are crossed. I'm sorry, I didn't.
Negative 6.
Yeah, negative.
I am with negative.
Negative 5 over x to 6. Oh, we got it right.
yeah. So when you see a situation like this, where you're eventually going to go probably is to get rid of the negative exponent here. That's where you're probably going to go. Not that you'd have to, absolutely. But for this one, what would you get? F prime of x equals negative 10 t to the negative 11th.
Right.
So we have this here, and then,
The T really threw me off. I kept writing X.
yeah. And what it is that often you're going to see that, you're going to see that often, where a little variable might throw you off or something.
Yeah, that.
So what it is, you get used to looking at things a certain way, and when they're a little bit different, you say, oh, what is this? But that's what test writers do a lot. They make things that aren't very difficult just sort of look confusing somehow, throw a different look at you. And so in the course, we're going to try to throw different things at you just to give you a chance to better understand what's going on. Okay, so this is going to be, what, 10t, is that it?
Yeah.
Okay, so just eventually when you do these things, and so who got all these right? Anybody get all these right?
I didn't get all of them, but I did.
You got most of them right?
Ow.
Oh, good job, good job, guys. Okay, good job. What I want to do is, now, what happens as you go through here, this part we're doing now is going to become like the easiest thing, and I mean, you can see it's pretty easy, right?
Light work.
Light work. And so what this becomes part of your arsenal of your skill, like this is your automatic stuff, right?
Well, at least
Where
I'm
you
not
just,
seeing this.
so this is you turning into calculus machines.
I am a calculus machine.
Calculus machines. What I want to do is I want you to look at this next set here and just look at these 13, 14. So work on these here.
Okie dokie.
Meanwhile, I'm looking for some other stuff. So, and then also, if you can, after you figure these out, try to put these into radical form too.
Right.
Remember we had the radical rational exercises yesterday?
Oh, the fractions is what it is.
Yeah. So try to see if you can do that.
So I did that to begin with. I'm stupid.
No, it's not, no, it's not stupid, it's smart.
That's the first thing I did.
Kylie.
No, that's good though. It's good, you're doing good.
5/3. 6. Oh, boy. Well, see how we're going.
Aaron, I'm about to act up.
Oh,
No doubt. Huh?
Oh, he might do it off.
Oh, no, it's on.
Do it.
You know other people watch it.
Nobody does.
He said he had 200 views.
Only because me and him was on that.
No, it wasn't just that one.
Ew, weirdo. What are you
what's
doing?
5/3 minus 1?
5/3 minus 1. 1 is the same as 3. So 5/3 minus 3.
Come on, it's a gymnastic.
Wait, which one? The frog or the... Yeah. Are you talking about this one?
Yeah. Give it.
What? Oh.
Come on.
What?
See if Maddie says.
We have to be there at 6:15 now. Oh, wait. That's for the game, not for the pepperoni.
Wait, the pep rally at 6:15?
I have to get fulfilled at 6:30 tomorrow morning.
Yeah, I have to be there at
Why?
7.
And full uniform image
Because
up
we
ready
have
to
to practice and get everything set up and get all y'all
That's
out
cool.
there.
I'm not even gonna show up for 9:45.
Why?
I'm gonna see you roll around on the field.
You'll see me in the front row because it's senior night and we talked.
Are they gonna make everybody walk down there?
Maybe.
Yeah, are we supposed to like walk down there?
No, we're all driving.
Jeez.
Bus ride.
Let's ride.
Bus right down this.
I'd rather walk. Enjoy the
I'd rather
day.
drive.
Unless it's pouring rain. Hey, could you imagine if it starts raining?
Low key.
Let me guess the kids. You can leave after we get the thing. That was good.
See somebody record it.
So, what you doing on 14? Are you on 14?
But it's not being in the front row.
Okay,
Let's
go over these here. So, for this one here, okay, we have y, so we're gonna have y prime is equal to 5/3 x, and what is this gonna be? 2/3? Does everybody agree with that?
No,
You don't agree with that?
I agree
just
with it.
because I thought we were doing something different.
That's what
Really? Okay. Yeah.
I thought we were
But it
doing
wants it-
different
it wants it
yesterday.
in
where
writing.
And so-
the square root.
And so what you have is what you have is y, and that's, the Hannah, that happens,
It happens.
happens, right? So that's gonna be equal to 5/3, and then that's gonna be something like this,
See, that's what I did.
right?
Just not with the two.
Yeah, so a differentiation, then a placing in radical form here. And then this one here, you have f prime of x equals, you take negative 7/4
Maybe, maybe 4.
x to the,
Hey, stay.
x to the,
Wouldn't that be negative 11/4?
negative 11/4. Does everybody see that?
But then you don't.
Because what you're doing is you're subtracting 1, which is subtracting 4/4, right? And so that's going to be f prime of x equals -7 over 4, and then we're going to have this kind of looking thing here. That's going to be 4. It's going to be x to the 11th down here, something like
Oh,
that.
I see what you did there.
Is that right?
Yeah.
Okay. Questions on that one? And Gavin, we did some of these types of conversions yesterday in class, and that's in the video that we did, right? Okay, next we have f prime of x here, so we're going to get 3/2 x to the 1/2. So I'm thinking like 3/2 square root of x, is that right?
Yeah.
And then this kind of thing you're going to see a lot, like number 16. So you have f prime of x equals
That'd be 1/2,
1/2 x to the
-1/2.
-1/2. And so you're going to have 1 over 2 square root of x. Is that right?
That's all I got wrong.
Yeah. Okay, so
Cutting.
so there we have some things there. What I want to do is, so I think I have some exercise I want you to work on here. I'm just going to hand them to you, have you just start working on them, have it be like your,
Also, that was like our last page in the notes. Or there's one page.
there's one more page left,
No,
that's it?
yes.
So here's what I want you to do, I want you to do these here.
That's a lot, Mr. E.
That is a lot, but it's good. It's a lot good.
So we're doing the same thing we just did on these?
It's the same sort of thing, but it's just sort of a mix-up of different things.
Can we use a different piece of paper?
Yeah, absolutely. You want to use a different piece of paper. Yeah. So my friends in the world,
I'm gonna number these.
we're looking at right here.
I'm gonna number these. So I don't know if I should do
You don't know how to work these?
No, I'm gonna number them, but I don't know if I should number it like 1, 2, 3.
Oh, okay, yeah, to me that's not super relevant. So this is what assignment was just being handed out, so repetition on,
I'm gonna do it.
all right?